Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Bachelor's Degree Programs, Bachelor of Computer Applications, BCA, Semester 2, BCSL-021 C Language Programming Lab, Lab Course, Section-1 C Programming Lab. 1.0 Introduction. This is the lab course wherein you will have the hands-on experience. You have study the support course material, MCS-011 Problem Solving and Programming. In this part, C programming under DOS, Unix and Windows environments are provided illustratively. A list of programming problems is also provided at the end of each session. Please go through the general guidelines and the program documentation. Guidelines carefully. 1.1 Objectives. After completing this lab course, you will be able to point develop the logic for a given problem. Point write the algorithm. Point draw a flow chart. Point recognize and understand the syntax and construction of C code. Point gain experience of procedural language programming. Point know the steps involved in compiling, linking and debugging C code. Point understand using header files. Point make use of different data structures like arrays, pointers, structures and files. Point understand how to access and use library functions. Point understand function declaration and definition. Point feel more confident about writing your own functions. Point be able to write some simple output on the screen as well as in the files. Point be able to write some complex programs. Point be able to apply all the concepts that have been covered in the theory course, and point know the alternative ways of providing solution to a given problem. 1 point to general guidelines. Point you should attempt all problems assignments given in the list session-wise. Point you may seek assistance in doing the lab exercises from the concerned lab instructor. Since the assignments have credits, the lab instructor is obviously not expected to tell you how to solve these, but you may ask questions concerning the C language or a technical problem. Point for each program you should add comments, i.e., text between ** delimiters above each function in the code, including the main function. This should also include a description of the function written, the purpose of the function, meaning of the argument used in the function and the meaning of the return value, if any. These descriptions should be placed in the comment block immediately above the relevant function source code. Point the comment block above the main function should describe the purpose of the program. Proper comments are to be provided where and when necessary in the programming. Point the program written for the problem given should conform to the ANSI standard. For the C language, point the program should be interactive, general and properly documented with real input-output data. Point if 2 or more submissions from different students appear to be of the same origin, i.e., are variants of essentially the same program, none of them will be counted. You are strongly advised not to copy somebody else's work. Point it is your responsibility to create a separate directory to store all the programs so that nobody else can read or copy. Point observation book and lab record are compulsory. These descriptions should be placed in the comment block immediately above the relevant function source code. Point the comment block above the main function should describe the purpose of the program. Proper comments are to be provided where and when necessary in the programming. Point the program written for the problem given should conform to the ANSI standard. For the C language, point the program should be interactive, general and properly documented with real input-output data. Point if 2 or more submissions from different students appear to be of the same origin, i.e., are variants of essentially the same program. None of them will be counted. You are strongly advised not to copy somebody else's work. Point: it is your responsibility to create a separate directory to store all the programs so that nobody else can read or copy. Point: observation book and lab record are compulsory. 1.3 Salient features of C. We briefly list some of C's characteristics that define the language and also have led to its popularity as a programming language. Naturally, we studied many of these aspects throughout the BCS-011 problem-solving and programming course. Point: small size. Point: extensive use of function calls. Point: structured language. Point: low level, bitwise, programming readily available. Point: pointer implementation, extensive use of pointers for memory, array, structures, and functions. Point: it has high-level constructs. Point: it can handle low-level activities. Point: it produces efficient programs. Point: it can be compiled on a variety of computers. 1.4 C programming using Boolean compiler. C using Boolean C++ compiler. Some of you may be using the Boolean C++ compiler during the lab sessions under MS-DOS connecting through Windows. Whilst C++ is a different programming language to C, it is in fact a superset of C, i.e. almost everything that C provides, C++ provides too, and more besides. Therefore, we can use Boolean C++ to compile our C programs. To start Boolean C++, click the Start button in the bottom left-hand corner of the screen. The Start menu pops up. Select Programs from the Start menu. Select Boolean C++ from the Programs menu. Select Boolean C++ from the Boolean C++ menu. In summary, the steps to launching Boolean C++ are: Start programs Boolean C++ Boolean C++. You should now see the main window for the C++ development environment. Editing a program. We can create a program by entering text that corresponds to C statements into a file. Setting directories. Before you proceed, make sure that the directory settings for Boolean C++ are correct. This can be done as follows. Select Options from the menu and then select Project from the Options pull-down menu. This will display the Project Options dialog box. In the Topics area, click on Directories. On the right-hand side of the window, you will see the directories listed. Ensure that the information in each of the fields is as given below. If it is incorrect, modify it accordingly. Creating Hello C. Point: select File from the menu and then select New from the File menu. The first thing that you should do is give the program a name, Hello C. Point: select File from the menu. Point: select Save As from the File drop-down menu. Point: in the Drives drop-down list box, click on the down arrow to open up the list box. Point: scroll through the list, select the drive and click on it. Point: click on the file name field and type Hello C. Point: make sure the file name has the C extension only. It should not have a CPP extension. If it does, change it to C or it won't run properly. Point: click on the OK button to continue. Point: now type the Hello C program exactly as you wrote in the lab observation book. Point: remember that it is good practice to save your programs periodically. You can do this as follows. Point: select File from the menu. Point: select Save from the File drop-down menu. Compiling a program. When you have finished typing in the program, you should compile it as follows. Select Project from the menu. Select Compile from the Project drop-down menu. An attempt will be made to compile your program. If there are errors, they will be reported in the message window. You should use the information provided to help you fix the problems and then recompile the program. Running a program. If you have successfully compiled your program, you can now link and run it as follows. Point select Debug from the menu. Point select Run from the Debug drop-down menu. First, an attempt will be made to link your program. If there are errors, they will be reported in the message window. You should use the information provided to help you fix the problems and then recompile and link the program. Your program now runs. The output from the program will be displayed in a separate window. If the screen displays a black output window for a split second and a window then disappears, it means you did not set the target output type before you compiled your program. To switch between the edit window and the output window, simply click on the window that you want to activate. To close the output window, point to the icon in the top left-hand corner and double-click on it. Alt plus F9, shortcut for compile and link. As you become more familiar with the Boolean C++ development environment, you will realize that it is possible to combine steps such as compile and link into a single step such as build all. There are also key combinations that can be used instead of selecting from menus, e.g. Alt plus F9 compiles the program. You should spend some time familiarizing yourself with the Boolean C++ development environment. To close the Hello C file, double-click on the icon in the top left-hand corner of the Hello C edit window. To quit from Boolean C++ compiler. To exit from Boolean C++. Point select File from the menu. Point select Exit from the File drop-down menu. Minimum hardware requirements for Boolean C++ compiler. This Boolean C++ compiler has a command line interface. You must run it from the DOS prompt. It has no graphical user interface like the version we use in the labs. What you are getting for free is not a good graphical interface we use in the labs. You get just the compiler, which is full spec, but you must drive it from the command line. To run the free C++ compiler, your computer must meet the following specifications. Point PC with a Pentium processor, 90 MHz or higher, P166 recommended. Point Microsoft Windows 95, 98, 2000, or NT 4.0 with Service Pack 3, or later. Point Microsoft Internet Explorer 4.01 Service Pack 1, included on CD-ROM. Point VGA or higher resolution monitor, Super VGA recommended. Point Microsoft mouse or compatible pointing device. Point 32 MB RAM, 64 MB recommended. Point disk space required for installation, 50 MB. 1.5 using C with Unix. A little knowledge of Unix operating system and commands is necessary before you can write and compile programs on the Unix system. Every programmer goes through the same three-step cycle. 1. Writing the program into a file. 2. Compiling the program. 3. Running the program. During program development, the programmer may repeat this cycle many times, refining, testing and debugging a program until a satisfactory result is achieved. The Unix commands for each step are discussed below. Writing the program. Unix expects you to store your program in a file whose name ends in C. This identifies it as a C program. The easiest way to enter your text is using a text editor like 6, Emacs or Zedit. To edit a file called testprog, C. Using 6 type. 6 test prog. C. The editor is also used to make subsequent changes to the program. Compiling the program. There are a number of ways to achieve this, though all of them eventually rely on the compiler, called CC on our system. The C compiler, CC. The simplest method is to type CC test prog. C. This will try to compile test prog. C and, if successful, will produce a runnable file called IGNOU. If you want to give the runnable file a better name, you can type CC test prog. CO test prog. This will compile test prog. C. Creating runnable file test prog. Running the program. To run a program under Unix, you simply type in the file name. So to run program test prog, you would type test prog. Or if this fails to work, you could type test prog. You will see your prompt again after the program is done. 1.6 Running C program using MS Visual C++. Visual C++ is one of the most powerful and popular general-purpose programming languages. It is an extension of C++ programming language. Microsoft's Visual C++ is an integrated development environment, or IDE. Microsoft Visual C++ has always been one of the most comprehensive and sophisticated software development environments available. It has consistently provided a high level of programming power and convenience, while offering a diverse set of tools designed to suit almost every programming style. Starting Microsoft Visual C++ 6.0. 1. On desktop, click on the Start button. 2. Select Microsoft Visual Studio 6.0 option. 3. Select Microsoft Visual C++ 6.0 option. You will see the main screen, Figure 1.1. Figure 1.1. Look at the screen.
4. Click Close. 5. After that you can see the blank interface like Figure 1.2. Look at the screen. 6. In the main screen select File menu, then click New. The new dialog box appears. You can see the screen like Figure 1.3. Look at the screen. 7. Select File at the new dialog box. Then, select C++ source file and click OK. The screen in Figure 1.4 will appear. A blank text editor window, code window will appear. Look at the screen. Creating a program. 1. Type your C source code in the text window as follows. Figure -1.5. Look at the screen. Save a program. 1. From the menu bar, select File and then select Save As. 2. Select the appropriate directory. In lab session, we will save all our exercise in directory desktop. So select Save in Desktop. 3. Type the name of the program file. Example, Program 1, C. You must save all source code in C extension, means that, all in, C. Click Save button. Compiling a program. 1. From the menu bar select Build and then select Compile Program 1, C or just click icon Compile. See below Figure 1.6. Look at the screen. You will get message that request you to need a workspace, so just answer yes to the question. Visual C++ will create default workspace and then build your code. This will produce a .obj program file. It does not have proper link with a library, built-in library, yet. If there are any program errors or warning messages, Visual C++ will display them in the message window, shown in Figure 1.7 below. If there are no errors or warnings, you can execute your program. Figure 1.7. Look at the screen. Executing, build, a program. 1. From the menu bar, select Build and then select Build Program 1.x. Or you can click Build icon. See below Figure 1.8. Figure 1.8. Look at the screen. 2. Now, the program code changes to .x files extension. This extension you can see at message window as shown in the Figure 1.9. Figure 1.9. Running a program. 1. From the menu bar, select Build and then select Execute Program.x. Or you can click Execute Program icon. See below Figure 1.10. Look at the screen. 2. Now, output will appear as shown in the figure 1.11. The output screen contains the printed results. Press any key to return to the program. Figure 1.11. Look at the screen. Let us see the steps involved in the program development life cycle. 1.7 Program Development Life Cycle. The 4 steps in the program development life cycle. Design algorithm. Draw flowchart. Program coding. Testing for various inputs. Example 1. Represent the complete steps in the program development life cycle that reads the number of letter grades A, B, C, D and F for a student. The program will compute and print the student's grade point average. It should then determine and print the student's academic standing, like high honors, satisfactory, or probation, according to the following table. Grade point average academic standing. 3.51 to 4.00 high honors. 3.00 to 3.50 honors. 2.00 to 2.99 satisfactory. Less than 2.00 probation. Note, in computing grade point average, assume that the weight of letter grade A is 4, B is 3, C is 2, D is 1 and F is 0. Step 1. Design the algorithm, pseudocode for the given problem. Print, please enter your number of subject that you're taken last semester. Set correct status input, no. Print, enter the number of grade A. Read number underscore of underscore A. Print, enter the number of grade B. Read number underscore of underscore B. Print, enter the number of grade C. Read number underscore of underscore C. Print, enter the number of grade D. Read number underscore of underscore D. Print, enter the number of grade F. Read number underscore of underscore F. Compute total underscore subject equals number of grade A plus number of grade B plus number of grade C plus number of grade D plus number of grade F. While correct status input, no, and total underscore subject less than equals 0. Begin. Print, enter number of grade A. Read number of A. Print, enter number of grade B. Read number of B. Print, enter number of grade C. Read number of C. Print, enter number of grade D. Read number of D. Print, enter number of grade F. Read number of F. If number underscore of underscore A greater than and equal 0 and number underscore of underscore B greater than and equal 0 and number underscore of underscore C greater than and equal 0 and number underscore of underscore D greater than and equal 0 and number underscore of underscore F greater than 0, and total underscore subject greater than 0. Set correct status input, yes. End if. End while. Compute total underscore point equals number of grade A asterisk 4 plus number of grade B asterisk 3 plus number of grade C asterisk 2 plus number of grade D asterisk 1 plus number of grade F asterisk 0. Compute total underscore average equals total point, total subject. Print total underscore average. If total underscore average less than 2. Print, your academic standing is probation. Else. If total underscore average less than 3. Print, your academic standing is satisfactory. Else. If total underscore average less than or equal 3.5. Print, your academic standing is honors. Else. If total underscore average less than or equal 4.00. Print, your academic standing is high honors. End underscore if. End underscore if. End underscore if. End underscore if. Step 2. Design a flowchart based on the algorithm. Look at the screen. Step 3. Translate the flowchart to C source code. Asterisk program to computer and print the grade point average. Hashtag include less than studio, H greater than. Main. Opening curly bracket. Int num underscore A, num underscore B, num underscore C, num underscore D, num underscore F, asterisk variables declaration part. Int total underscore subject. Int total underscore point. Float GPA. Do. Print F, T this is for calculate your GPA, N. Print F, enter number of grade A. Scanf, %D, and num underscore A. Print F, enter number of grade B. Scanf, %D, and num underscore B. Print F, enter number of grade C. Scanf, %D, and num underscore C. Print F, enter number of grade D. Scanf, %D, and num underscore D. Print F, enter number of grade F. Scanf, %D, and num underscore F. Asterisk calculation of the total. Total underscore subject equals num underscore A plus num underscore B plus num underscore C plus num underscore D plus num underscore F. Opening curly bracket. If num underscore A less than 0, num underscore B less than 0, num underscore C less than 0, num underscore D less than 0, num underscore F less than 0, total underscore subject less than equals 0. Print f, you should enter your number that you having take again, n. Closing curly bracket. While, num underscore a less than 0, num underscore b less than 0, num underscore c less than 0, num underscore d less than 0, num underscore f less than 0, total underscore subject less than equals 0. Asterisk this to calculate and print total underscore subject, total underscore point and GPA asterisk. Total underscore point equals num underscore a asterisk 4 plus num underscore b asterisk 3 plus num underscore c asterisk 2 plus num underscore d asterisk 1 plus num underscore f asterisk 0. GPA equals, float, total underscore point, total underscore subject. Asterisk this to print total subject. Print f, n your grade point average is %.2 f, n, GPA. Asterisk this selection to get output the student's status. If GPA less than 2. Print f, your academic standing is probation, n, n. Else, if GPA less than 3. Print f, your academic standing is satisfactory, n, n. Else, if GPA less than equals 3.5. Print f, your academic standing is honors, n, n. Else, if GPA less than equals 4.00. Print f, your academic standing is high. Honors, n, n. Return 0. Closing curly bracket. Step 4. Testing. Output. This is for calculate your GPA. Enter number of grade A, 3. Enter number of grade B, 2. Enter number of grade C, 2. Enter number of grade D, 0. Enter number of grade F, 0. Your grade point average is 3.14. Your academic standing is honors. 1.8 List of lab assignments, SESSIONWISE. Session-1. 1. Develop algorithm, flowchart and write an interactive program to calculate simple interest and compound interest. 2. Design a flowchart and write an interactive program for the problem given below. Assume that the United States of America uses the following income tax code. Formula for their annual income. First 5,000 United States dollars of income, 0% tax. Next 10,000 United States dollars of income, 10% tax. Next 20,000 United States dollars of income, 15% tax. An amount above US dollar 35,000 is to 20% tax. For example, somebody earning 38,000 United States dollars annually would owe 5,000 United States dollars by 0.00 plus 10,000 x 0.10 plus 20,000 x 0.15 plus 3,000 x 0.20. Which comes to 4,600 United States dollars. Write a program that uses a loop to input the income and calculate and report the owed tax amount. Make sure that your calculation is mathematically accurate and that truncation errors are eliminated. 3. Design a flowchart and write an interactive program that reads in integers until a 0 is entered. If it encounters 0 as input, then it should display the total number of even and odd integers, average value of even integers, average value of odd integers. Note, use switch statement for selection. 4. Write an interactive program to generate the divisors of a given integer. Session 2. 5. Write a program to find all Armstrong number in the range of 0 and 999. Hint, an Armstrong number of 3 digits is an integer such that the sum of the cubes of its digits is equal to the number itself. For example, 371 is an Armstrong number since 33 plus 73 plus 13 equals 371. 6. Write a program to check whether a given number is a perfect number or not. Hint, a positive integer n is called a perfect number if it is equal to the sum of all of its positive divisors, excluding n itself. For example, 6 is a perfect number because 1, 2 and 3 are its proper positive divisors and 1 plus 2 plus 3 equals 6. The next perfect number is 28 equals 1 plus 2 plus 4 plus 7 plus 14. The next perfect numbers are 496 and 8128. 7. Write a program to check whether given two numbers are amicable numbers or not. Hint, amicable numbers are two numbers so related that the sum of the proper divisors of the one is equal to the other, unity being considered as a proper divisor but not the number itself. Such a pair is 220,284 for the proper divisors of 220 are 1, 2, 4, 5, 10, 11, 20, 22, 44, 55 and 110, of which the sum is 284, and the proper divisors of 284 are 1, 2, 4, 71, and 142, of which the sum is 220. 8. Write a program to find the roots of a quadratic equation. Session 3. 9. Write a function invert, x, p, n, that returns x with the n bits that begin at position p inverted. You can assume that x, p and n are integer variables and that the function will return an integer. As an example, if x equals 181, decimal, which is 10,110,101 in binary, and p equals 4 and n equals 2, then the function will return 10,101,101 or 173, decimal. The underlined bits are the changed bits. Note that bit positions are counted from the right to the left and that the counts start with a 0. Therefore, position 4 is the fifth bit from the right values. 10. Write a function that calculates the compounded interest amount for a given initial amount, interest rate and number of years. The interest is compounded annually. The return value will be the interest amount. Use the following function definition: float comp underscore int underscore calc, float int underscore unt, float rate, int years. Write a program that will accept the initial amount, interest rate and the number of years and call the function with these values to find out the interest amount and display the returned value. 11. Break up the program that you wrote to solve problem 10 into two separate source files. The main function should be in one file and the calculation function must be in another file. And modify the program so that the interest rate is a symbolic constant and is no longer input from the keyboard. And put all the C preprocessor directives into a separate header file that is included in the two program source files, i.e. #include, header, h. 12. Define two separate macros, min and max, to find and return, respectively, the minimum and maximum of two values. Write a sample program that uses these macros. Hint: use the ternary operator. Session 4. 13. Write a program that will take as input a set of integers and find and display the largest and the smallest values within the input data values. 14. Write an interactive program that will take as input a set of 20 integers and store them in an array, and using a temporary array of equal length, reverse the order of the integers and display the values. 15. Write an interactive program to do the following computation by providing the option using the switch statement. Add two matrices. Subtract two matrices. Multiply two matrices. Session 5. 16. Write a program to check if the given matrix is magic square or not. 17. Write a program print the upper and lower triangle of the matrix. 18. Write a program to compute transpose of a matrix. 19. Write a program to find the inverse of a matrix. Session 6. 20. Using recursion. I. Find the factorial of a number. E. Find greatest common divisor, GCD, of two numbers. E. To generate Fibonacci sequence. IV. Reverse, n, characters. Session 7. 21. Write a program to convert a given lowercase string to uppercase string without using the inbuilt string function. 22. Write a program to count number of vowels, consonants and spaces in a given string. 23. Write a program to input a string and output the reversed string, i.e. if USF is input, the program has to output FSU. You are not to use array notation to access the characters, instead please use pointer notation. Session 8. 24. Write a program to process the student's evaluation records using structures. 25. Define a structure that will hold the data for a complex number. Using this structure, please write a program that will input two complex numbers and output the multiple of the two complex numbers. Use double variables to represent complex number components. Note: a complex number z is a number of the form z equals a plus b, where a and b are real numbers. The term a is called the real part of z and b is called the imaginary part of z. The multiplication operation on complex numbers is defined as a plus b, c plus d, equals ac, bd, plus add plus bc, I. 26. Modify the above program so that the multiplication is carried out in a function that accepts two complex number structures as input parameters and return a complex number structure with the result. Session 9. 27. Write a function that will return the length of a character string. You are not allowed to use the strlac library function. Note: use pointers concept. 28. Write a function that returns the minimum and the maximum value in an array of integers. Inputs to the function are the array of integers, an integer variable, containing the length of the array and pointers to integer variables that will contain the minimum and the maximum values. The function prototype is void minmax, int array, int length, int min, int max. 29. Write a sample program that uses this function to find and display the minimum and the maximum values of an array of integers. Use an array of 10 integers. You can either use scanf to input the values into that array or initialize the array with values in the program itself. Session 10. 30. Write a program that prompts the user the name of a file and then counts and displays the number of bytes in the file. And create a duplicate file with the word backup appended to the file name. Please check whether file was successfully opened and display an error message if not. 31. Write a program to create a file, open it, type in some characters and count the number of characters in a file. 32. Write a program that will input a person's first name, last name, SSN number and age and write the information to a data file. One person's information should be in a single line. Use the function fprintf to write to the data file. Accept the information and write the data within a loop. Your program should exit the loop when the word exit is entered for the first name. Remember to close the file before terminating the program. Hint: use the function stracemp to compare two strings. 33. Modify the program number 23 using file concept. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.